off with, we have 3 grams of lead-2 nitrate and 2 grams of potassium iodide. This is the balanced equation for our experiment. Potassium iodide in an aqueous state plus lead-2 nitrate in an aqueous state gives us potassium nitrate in an aqueous state plus lead iodide in a solid state. We first found out the molar mass of potassium iodide, which is 65.99 moles per gram, and then we divided that by 3 grams, which gave us the mole of potassium iodide, which is 0.05. And then we converted lead-2 nitrate to its molar mass, which is 33.21 moles per gram, and then we divided it by 2 grams to get 0.01 moles. We converted it to moles so it would be easier to work with when calculating our limiting reactants and our theoretical and percent yield. So we multiply 0.05 moles of potassium iodide by 1 mole of lead-2 nitrate divided by 2 mole of potassium iodide, which gives us 3 mole of lead-2 nitrate, which is not possible because we only have 3 grams of lead-2 nitrate, or 0.01 moles, which means that lead-2 nitrate is the limiting reactant. So now we multiplied 0.01 mole of lead-2 nitrate by 2 mole of potassium iodide over 1 mole of lead-2 nitrate, which gave us 0.02 mole of potassium iodide, which is possible since we have 2 grams of potassium iodide, which is also 0.05 mole. So since we only used up 0.02 mole of potassium iodide, we have 0.03 mole of potassium iodide left over, which means that potassium iodide is the excess reactant. To calculate the theoretical yield, we needed the limiting reactant, which we found was lead-2 nitrate. So we multiply 0.01 mole of lead-2 nitrate by 1 mole of lead iodide over 1 mole of lead-2 nitrate, which gives us 0.01 mole of lead iodide. And so now we have to convert lead iodide into grams. So we multiply 0.01 mole of lead iodide by 461.2 moles per gram of lead iodide over 1 mole of lead iodide, which gives us 4.612 grams of lead iodide, and we needed to convert it to grams so we could calculate the percent yield. The actual weight of our final product was 2.45 grams. In order to find the percent yield, we divide the actual yield by the theoretical yield and multiply by that by 100 to get our percent yield. So our actual yield is 2.45 grams divided by 4.612, which is our theoretical yield, and we multiply that by 100 to get 53%, which is our percent yield.